Hello, here's your lesson for Unit 2, Section 5, Algebraic Proof with Missy McCarthy, Okemos High School Math Instructor. So, we need to talk about what is a proof. A proof is just an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So we've been talking an awful lot about definitions and properties and logic and the use of deductive reasoning. So if you put all of that together and you demonstrate that something has to be true, you show that the conclusion has to be true, then you have written a proof. If you've ever simplified an expression or solved an equation in algebra, then you've really done a proof. Let's see how. You might remember this from our Algebra 1 course. It said use deductive reasoning as a process of logical reasoning from facts to a conclusion. So if you had a statement here like negative 4b plus 9 plus b and you were simplifying it, every time you completed a step of simplification, there was a property that you could use to justify that simplification. And so therefore, you were using logic and properties and facts and definitions and rules, and you were doing deductive reasoning to simplify that expression, which is just a short form of a proof. So here are some properties that we often use when we are solving equations or simplifying expressions, and they're going to be used in our proofs. We have the addition property of equality, subtraction property of equality, multiplication property and division property. The reflexive property is often used in geometric proof. The symmetric property, have you ever gotten an answer that said 6 equals x? All you have to do is rewrite it as x equals 6 because of the symmetric property of equality, the transitive property, and the substitution property, which allows you to replace one item with another if they are equivalent. So here are all of our properties of equality that we may end up using. So we're going to solve this particular equation, and we're going to justify each step with a property. So our steps are going to start off with 4m minus 8 equals negative 12. And our justification for that is that's what we are given. Now the next thing you might want to do is add 8 to both sides. So we have 4m minus 8 plus 8 equals negative 12 plus 8. And that is the addition property of equality that allows us to do that. So we can combine our like terms and get 4m equals, negative 4. That would just be simplification or addition. Oftentimes we write addition as to what we actually performed there. Then we might want to divide both sides by 4. So 4m divided by 4 and negative 4 divided by 4. And that's the division property of equality that allows us to do that. So we have m equals negative 1, which is just simplification. Or we can say we actually just performed the division. And we have just done a form of algebraic proof. We use logic, properties, and reasoning to get from 4m minus 8 equals negative 12 to m equals negative 1. So here we're going to apply it to a real life problem. It says, what's the temperature in degrees Fahrenheit F when it is 15 degrees Celsius? We have to solve the equation for F and then justify each step. So we need to make sure we understand the problem. We want to find the Fahrenheit if the Celsius temperature is 15 degrees. So the Celsius temperature is 15 degrees, and our Fahrenheit temperature can be found by 9/5 times our Celsius temperature plus 32. So I understand the problem. Now my plan is going to be to use my substitution property and then simplify. Substitution and simplify. So here we go. First, I am going to use substitution to replace the C with 15. And then I'm going to simplify. 9/5 times 15 is 27 plus 32. And I end up with a Fahrenheit temperature of 59 degrees. So does that make sense? Yes, if the Celsius temperature is 15 degrees and we're going to take 9/5 of it, which is more than one of it, and we're going to add 32 to it, oops, I'm sorry, we should end up with something that is bigger than 15 degrees, and then 59 degrees makes sense as our answer. So like algebra, geometry also uses numbers and variables and operations. So we are going to solve this problem using the segment addition postulate and we're going to justify each of our steps to prove that x, or the value of x in this situation, is 5. So if we look here, we have a segment NO, which is composed of segment NM and MO. We have our algebraic representations for each of those segments. So we can say that NO equals NM plus MO. Our justification would be the segment addition postulate. So then, if we represent NO with 4x minus 4, represent NM as 2x, and MO as 3x minus 9, all we have used is our substitution property. So here, if we distribute the plus there, and then we simplify that, actually we have combined like terms or also used the distributive property. And then it looks like there was a 4x subtracted from each side to get negative 4 equals x minus 9. So that is the subtraction property. And then lastly, 9 was added to both sides to get x equals 5, which would be the addition property. So we have proven that the value of x is 5 in this scenario. Now we also have some properties of congruence that we use. The reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence. So you can see those there. Symmetric property just says segment EF is congruent to segment EF, or any figure is congruent to itself. The symmetric property says if figure A is congruent to figure B, then figure B is congruent to figure A. And the transitive property is similar to the law of syllogism. If figure A is congruent to figure B, and figure B is congruent to figure C, then figure A is congruent to figure C. So we'll use those three properties as well. Okay, so here we just have to identify which of those properties are demonstrated in this example. So angle QRS is congruent to angle QRS. That is our reflexive property of congruence. Here, if the measure of angle 1 equals the measure of angle 2, the measure of angle 2 equals the measure of angle 1. That is actually the symmetric property of equality. Notice that there are equals there, no congruence. If segment AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. That is the transitive property of congruence. And lastly, 32 degrees equals 32 degrees is the reflexive property of equality. And that's it for our properties and algebraic proof.